12.6, solving problems involving quadratic equations. It's not that hard. We know how to solve quadratic equations. We can factor them. We can use the quadratic formula. We can complete the square. There are lots of different ways that we can, well, we have 3 different ways that we can solve quadratic equations, okay? Let's see if we can apply that to these word problems. If you look at example number 1, it says the Parks Commission wants a new rectangular sign with an area of 25 meters squared for the visitor center. Okay, so I know it's going to be a rectangular sign. Okay, there it is. The length of the sign is to be 4 meters longer than the width. So if this is the width, then the length needs to be 4 plus the width, right? Okay. Now, to the nearest tenth of a meter, what will be the length and the width of the sign? Well, I know that the area is supposed to be 25 meters squared, so that means that W times W plus 4 needs to equal 25. Okay? All right, well, let's simplify this. Let's multiply it all out and get everything on one side, and then we'll see how we want to solve this. So W times W is W squared. W times 4 is 4W is equal to 25. Okay? This looks like completing the square might be best. You know, I mean, factoring is not going to work. Let's see. Let's subtract 25 from both sides, just to see. W squared plus 4W minus 25 is equal to 0. Now, I know that the only things that go into 25 are 1 and 25 and 5 and 5. None of those pairs are going to give me 4. So factoring is not really going to work. I can use the quadratic, but you know what? I think that completing the square is going to be faster. Let me add 25 to both sides. Okay? So I'm going to get W squared plus 4W plus something is going to equal 25 plus something. Okay? Remember, when we're completing the square, we take the number next to the W, next to the linear term, and we say that divided by 2 is equal to 2. And then we square it. That's going to give us 4 here and 4 there. Okay? Now, this stuff on this side is going to be W plus 2 squared. We know that. Okay? And on the other side, I'm going to get 25 and 4 is 29. Okay. Well, you know, that's not going to be that easy. I mean, it's not going to be that clean. It's going to be easy. Okay? So we take the square root of both sides, and I'm going to get W plus 2 is equal to plus or minus the square root of 29. So now subtract 2 from both sides, and I've got W is equal to negative 2 plus the square root of 29 and negative 2 minus the square root of 29. Now before I go anywhere, I know that this is going to be a negative number, so I can just go ahead and cancel that out. Okay, I'm not going to be able to use that one at all. But let's look at this one, because the width can't be a negative number, right? Remember, this is a rectangular sign. Okay, now the width is going to equal negative 2 plus, well, what is the square root of 29? Let me get my trusty calculator here. Is it trusty? I don't know. If I put it in correctly, it's going to work right. 5.385164807. Okay? Now, let's see. Negative 2 plus that is going to equal 3.385164807. Now they said round it to the nearest tenth, right? Okay, so I'm going to block off the number that's in the tenth spot. I'm going to look at the number right outside. That's big enough, so the width is going to equal 3.4 meters. Is that right? This is in meters, wasn't it? Yeah. Okay, now that's the width. Remember, the length is supposed to be 4 meters longer, so that's going to be 7.4 meters. Okay? So those are our dimensions. I can just test it. If I multiply 3.4 just to find the area, now remember, it's not going to be 25 because we rounded. Okay? 3.4 times 7.4, that's going to give me 25.16 meters squared. Pretty close. We rounded, that's why it's off. Okay? But that's nice. And I think completing the square is the best. Could I have used the quadratic formula? Sure. Could I have factored? Not really, because the things didn't break down nicely for us. Okay? Let's look at example number 2 here. It says the length of a rectangle. Okay, here we go, another rectangle. the length is 3 times the width. Well, if this is the width, then this is 3 times the width. Okay, now it says the area of the rectangle is 75 centimeters squared. So that means that 3W times W is equal to 75, Okay, well, let's simplify. That's 3W squared, right? Is equal to 75. Man, this is like section 1. Just divide both sides by 3, and now W squared is equal to 25. Take the square root of both sides. That means that W is equal to plus or minus 5. Wait a minute. Can the width be minus 5? No. So the width has to equal 5 centimeters. So this is 5 centimeters. This must be 15 centimeters. And if I multiply 5 times 15, I'm going to get 75 centimeters squared for the area. Nice. Man, that was a piece of cake. Cake, man. All right, let's look at the next one. The difference of a number and its square is 182. Well, remember, a difference is a subtraction problem. So the difference between a number and its square is 182. Okay. Well, you know, it's a quadratic, so I want to get everything on one side. But you know what? I don't want this thing to be negative. You know what? I'm going to add x squared to both sides. How about that? So now I've got x is equal to x squared plus 182. Now I'm going to subtract x from both sides. Now I've got x squared minus x plus 182 is equal to 0. I'm just going to flip the 0 on the other side. That's all right, guys. Now, that's a big number. And I'm betting, because these are teachers, it's going to come out nice and pretty. Okay? So, you know what I'm going to do? I'm going to try factoring this. Hey guys, I'm sorry I got interrupted there for just a second, but that's okay. Look, 182. I'm going to factor 182. 182 is 2 and 91. 91 is 3 and 7. So if I use that, right, that's 2 times 3 times 7. I know that 182 is equal to 1 times 182. Does 2 go into it? Sure. 2 times what? 2 times, oh, whoa. This is 13. Not 3. 2 times 7 times 13. Okay, how many times does 2 go into it? Well, 7 times 13, right? 91. Okay, well, what else goes into it? 7 goes into it, right? So 7 times what? 7 times 2 times 30 is 26. Okay? All right, let's see. What about 13? 13 goes into it. 13 times what? 13 times 14. Okay, oh, look. I've got a pair that's just 1 apart. So it's going to be x, I want it to be negative, minus 14, x plus 13 equals 0. That means that x equals 14 or negative 13. Now let's check them. Let's see if that's true. It says the difference between a number and its square is 182. Okay? All right. The difference between a number and a square, 14 minus 196 is equal to negative 182. Right? A number and its square. What about this one? Negative 13 minus 169. What's that going to be? Negative 182. Okay. That's interesting, because I think that's supposed to work out right, but they've got negatives in there. You know, I mean, if I flipped it around, if I did 196 minus 14 is equal to 182, that's true. And 169 minus negative 13, okay, that's definitely true also. Okay. I say, okay. Alright. The difference between a number and its square. I suppose that it, no, we're supposed to do it in what, you know what? I think this problem is incorrect. I think there is no solution. the difference between a number and its square should be negative 182. If you do it in order the way they say, a number and its square, right? You're supposed to write a difference in the order in which they give it to you. It should say the difference of the square of a number and itself is positive 182. So the way they have it written, no solution. I don't think they meant that. I think they just wrote it wrong. Okay? Let's look at this next example. Okay, but that was an easy one to solve. Okay? Example number 4, Holly has a rectangular garden. Oh, nice. That's nice, Holly. It measures 12 by 14. So this would be 12 and this would be 14. Okay? Now she wants to increase the area to 255 meters squared, right, by increasing the width and the length by the same amount. So I need to increase the width by x and the length by the same amount, x. What will the dimensions of the new garden be? Well, I don't know, but let's see. Right? Let's do, instead of that, I'm going to do x plus 14 times x plus 12 needs to equal 255. Okay? So x squared plus 12x plus 14x plus 168 is equal to 255. Okay? X squared plus 26x plus 168 is equal to 255. Now I'm going to subtract 255 from both sides, and I'm going to get that x squared plus 226x minus 87 is equal to 0. I could use the quadratic. I could complete the square, but if I complete the square, that's going to be some big numbers. You know, 13, 169, I don't know. Let's complete the square. I'm going to add 87 to both sides. So now, oh, Mr. C, you're going crazy. X squared plus 26x. I just like having options, being able to do whatever I want to do. Plus something is equal to 87 plus something. What is that something? Well, it's 26 divided by 2 squared, isn't it? So that's going to be 13 squared, so that's 169. 169. Wait, we just did this. So x squared plus, oh, but wait a minute. This is going to be x plus 13 squared is equal to 255. Okay. Alright, I don't like that. I don't like that. Because that's not going to come out pretty. And I want it to come out pretty. So, let's go back up here. And let's see if I can factor this thing. 87. 87. Get rid of that. That's going to be 1 and 87. I mean, 1 times 87. 2 doesn't go into it. 3 goes into that. 29 times. Oh, look at that. They're 26 apart. X minus 3 and x plus 29 is equal to 0. That means that x can equal 3 or x can equal negative 29. Well, it can't equal negative 29. It has to equal 3. So that means I'm going to get 15, and then this is going to be 17. And is that right? 17 times 15, does that give me 255? 35, that's 8, 0, 7, 1, 5, 2. Woo! 15 meters by 17 meters. Nice. Man, that quadratic equation, we got problems that we can solve using that thing. Remember, complete the square, quadratic formula, factoring. I factor when I can. That seems to be the fastest. Completing the square is not bad either. Quadratic formula always gets you the right answer, but it takes time. Okay? All right, guys. Nice job. You're ready.